talk about data pre-processing. So this is a wonderful topic. Okay, okay. Our jokes apart, we'll start from the data pre-processing. See, whenever you are, EDA is known as explorative data analysis. Data analysis, right? EDA is for analysis. But if you want to train a machine learning model, ML model, let's say you want a model to verify some digits what you have written. Let's say I have written my phone number, something, some, I don't know what I'm writing, but okay. So how many of you can tell this is 9? Multiple people. How many can tell this is 5? 5, 1, 7, 8, 9. See, there might be some issue. It can be 5 also, like alien handwriting, but still it's 9. So 9 and 6. So you are just recognizing it. So if you put a क्या कहते हैं इसको, handwritten digits prediction something classification, then in that case we need to train it on multiple data. Your data might look like this, your data might be look like this, and different things, small 9 or some, this is also 9. So multiple things can be there. No, there are multiple ways of writing 9. Some as somebody like said G. So the point is, pre-processing stands for whenever you are going to feed your model, before feeding the data to the model, is it in the right format and is it in the right way we are going to train the model on. Let's say this is your model, right? So the point is, what you will do, for example, let's say this is also a 9, right? Say yes or no. This is also 9. Yeah, great. This is also 9. But the model can't understand this 9. You have to convert into this format. This is known as data pre-processing. Although your data is correct, because you can't do analysis over here. You don't have to do any kind of analysis on this 9, this 9, this 9, this 9, this 9, this 9. The point is, you have to some pre-processed, like pre-processed, yeah, pre-cooked chapatis are there, no? Same way, pre-process your data to train the machine learning model, right? This is the whole concept. Means removing any, it can be outlet removal also, it can be your data cleaning also, it can be normalization also, that min-max scalar. So all the topics comes under this part, data pre-processing. For example, if let's say we are doing PCA. Do you guys remember PCA? That dimensionality reduction in unsupervised. एक सेकेंड. अच्छा, okay. Okay. So, by the way, there is one good point. We got the access of phone pay payment gateway. Means now you don't have to scan my QR code. You have to use the website and you can pay for the courses or whatever. We'll try to integrate for AI works also over here. Because in future, definitely, if I am taking the event, it will be क्या कहते हैं, collaborated with Human Care Foundation. For every event, the next 5th and 6th, definitely yes. And if you have guys done HCF internship or something special will be there for you. Alright, so this is a good thing. Like right now I got a message. So phone pay payment gateway. Okay, although the people who is watching on YouTube, sorry, but I have to tell because my students, my friends, my brothers are there only. So okay, so we are talking about PCA. The PCA is also a kind of unsupervised learning. Not kind of, it is a type of unsupervised learning. So similarly, if you want to do like transform some small features into more smaller features. For example, only important things we need for let's say this is a cylinder. So what are the key features? It has only this and lines. Yeah, we got this is the smaller feature. So this is how PCA works, right? And my screen is not working. That's why I hate this stuff. Mommy, yeah, see. Something might be there, no? Canvas, no. Yes, no. Yes. But that won't be recorded. I can't share. Okay, we'll do new document. Blank. Let's try if I can do it over here or not. Something might be there, no? Yo. Is there any paint or something? Paint. I be serious. Google Jamboard is disabled. Microsoft Evernote. Evernote. And get Evernote free. Yes. Installing will take time for my work, for my productivity. Let's continue with Google. Go to Evernote. Is it working now? No, it's not working. Ah, brother, go to Evernote. Made with love by bending spoons. Nice. Capture every idea. Okay, okay. School personal. Store and online capture idea. Capture ideas quickly. Array. Okay. Continue with free trial. Give me no. You're making this much bullshit. I want to go to F1. I want to create a page. Does anybody know some other website? I'll do Canva, but the notes will not be shared, so you guys have to take a screenshot. Just a second. I'll create a page. Okay. Yeah. Sorry for the disturbance. Okay. So this is only the basic thing, the data pre-processing. This is a little bit difficult, but okay. It is the basic thing which we use to clean or transform the raw data into a meaningful data, which we require for the analysis. So whenever we have a data, we clean it first. Like you can call it cleaning or transforming. Clean or transform the data. Uh, which data? The raw data into the data which we use for the data analysis part. Like uh, further we do data analysis on it. So means making unuseful data into a useful data. That is known as data pre-processing. of the steps what you guys know, it's already there, like for example handling the missing values, or if it is not normalized, if it is having outlets, so removing outlets, or if it is not normalized, so making it normalized by values, or something format issues. Right now what I've shown 9 and 9, 9 and this 9. So this are the examples of the data pre-processing what we do usually in our making data sets, right? Any doubt till here what is data pre-processing and how it is different from EDA? Anyone? And for this you have to take a screenshot, guys. I can't, if I remove, no, I think so it will be gone. See, it went off and there is nothing to draw. I'll find some another tool, or we can create easily using Python. No, we can create a tool to write using a mouse pointer or something. So I'll try creating. Try free form. Okay, brother. Okay. Okay. Right now we should proceed with our, what do you say, this class part. I'll later set it up. See, you can ask okay, why we should be doing this data pre-processing. So DPP, not daily practice problem, but data pre-processing. Pre-processing actually comes under one term only, pre-processing. So for your own ease, you can say DPP or DP is also fine. So data pre-processing helps you to enhance the quality of your data, enhance the quality. It also helps you to quality. See, once you remove the unnecessary, for example, removing missing values or outlets, so it definitely make the data more streamlined, right? For example, earlier the data was something like this. Now you found something wrong. Okay, this is the waste. This is also waste value. This is a good value I should keep. This is a waste value again. So the value should be this, and you made it like this, right? So now what's the point? This data is more streamlined as compared to this, right? This much have a lot of the difference between the data points. This is less, but this is not meaningful. This is meaningful. The output or the target value or the training the column which we are gonna train on to predict for is more accurate in this one as compared to this one. So this data is far better than this in terms of training machine learning model. Reason being, less outliers, no missing values, proper alignment of the data with the rest of the part. So this increases your model performance. You should know that data pre-processing increases the model performance. That's why we do. Again, if model performance is good and the data you have removed, like handling missing points and unnecessary, like deviation in your life, multiple things are there, no, Instagram, relationships, then Snapchat, here, family. So if you remove all these types of distraction from your way, you will have only one thing, you and your work to do, and that's how you proceed. Same way, if you remove these types of stuffs from the data, what you will have only the data which is to the point, correct? So model performance will increase, and again, if less distractions are there for the data, definitely the training time also reduces. The time to training time means the time taken by any model to get trained on based on the data what we have provided. So as you remove this, as you do data pre-processing, it will help the model to decrease the training time. So less training time means the earlier your model will be. For example, you can say, bhaiya, we tried, we can make within 3 seconds or 4 seconds. Maximum it will take this much time. Brother, it is true. Because for the data, when you have very less number of rows, let's say 30,000, 40,000, or very less, or 2,000 something. But if you are training on a multiple and a huge data, for example, 3 lakh, 4 lakh of the rows, at that time, 1 second also matter. A lot matters. Exactly right now, if you are training now, and if you are doing some analysis part or research part, and you're seeing that after dropping some of the features, dropping means removing, after removing some of the columns, you are finding that your training time is getting reduced. That means actually that was not necessary, and your accuracy boosts That means 100% that data pre-processing technique was the best thing what you have done for the model improvement. Any doubt, guys? Any kind of doubt? If you have, don't ask me, ask ChatGPT. Okay. How many of you know how to make coffee? Raise your hand. 12 out of 20, 22. Gee, same on you, rest of 8 of you. 7, 6. Jayesh is there in the class. Jayesh, you know how to make coffee?
Yeah, obviously. I live on that.
Okay, guys, if you're a true engineer, this is the basic requirement. Okay, guys, this is for the joke. Okay, to bring your focus back on the track. Let's continue. Okay, so how to clean this? Manually. Uh, or if I go back and forward, does it allow me? Array, add page, add page, add page, add page, add page. Okay, guys, let's go back to the second page. Somebody's mic is muted. I can hear some of the noise. Kindly mute if your mic is unmuted. And let's draw on this page. Yeah. So this is the basic requirement. Okay. So it helps in multiple ways. You can write data pre-processing in your notes. First was that removing bullshit things will increase your data quality. Another performance which we get, like that was model performance. Sorry, model performance increases, data quality increases, model performance increases. Then what we had, training time. Training time increases. Sorry, decreases. See, then what else? I told you three only now. So what happens if you do data processing? We are removing unnecessary stuff. Underfit and overfit. I'll teach this topic now. And one more thing is this. We can say like explainable, explainability increases. This is a made up term, explainability. If it is correct, then fine. No means you guys can change as per your need. Underfit and overfit. I have shown you. I have already told you what is underfit, what is overfit based on the data, right? Some graph was there. The same thing will happen. Underfit and overfit, you knows the meaning. The point is how. The more your data are and to the point strictness you have given, the more the data will be overfit, right? And if you have given less, very less, if the values are very in range, for example, one data point over here, one data point here, one data point here, and going something like this only, and somewhere here, like there is too much of the distractions or the distance between two of the points. That means you are gonna the model will be underfit, right? So to decrease this problem, to reduce this problem, what we can do, we can reduce the distance when we need only the main data what we have. So removing the outliers or handling the missing values will come under this part also, right? Or making, if the data points are too much at a distance, we can do this logarithmic. You guys remember that logarithmic normalization part where you can take a log on the data. So if 1024 is there and 64 is there, so this will become 10, this will become 2 power 4 is 4 4 16, 16 into 2 32, 6, this will become 6 and 10. So the data earlier 64 and 1024, now they have become 6 and 10 next to each other. So this is how you solve underfit, right? So this increases the underfit and overfit problem, reduces the problem. Another is explainability increases. For example, whenever you have selected some of the features or Why this is happening like this way, you'll get more because now the distractions are removed, only you have to focus on particular thing, right? So that's how explainability increases. Any doubt till here, guys? Any kind of doubt? Why like in what terms it will help to us? This is the topic, like how dp help us. And most of the data pre-processing text we have done already. All right. And before going for the data pre-processing, we should go for the data, and I have already taught the what type of data are there, and we'll do the revision part because this is the particular topic. Okay. And how it is, like what are the step by step process we should be doing. Today is the theoretical part. Tomorrow we can go for the, we will not go for the क्या कहते हैं coding part for this. We'll be soon developing. I have already forgotten the timetable of this week. If there is any model like linear regression or logarithmic regression, linear, yeah, and logistic regression. So if these two topics are there in this week, definitely we are gonna train that model, and in that at that time we'll come to know why DP and how we are gonna execute, because most of the code are similar like what we have performed in the EDA session. So anybody have any kind of doubt till now? Because now I'm gonna talk about some basic things what we have already taught, like data, what is type of data, very fast, and within 2-3 minutes we'll cover. So anybody have any kind of doubt? Yeah, Dia, hello. You have raised your hand, that's why I'm asking. Yeah, if you have raised your hand, that means you have doubt. Okay, guys. So if you have doubt, just raise your hand. Okay. So I'll proceed then, right? Put a thumbs up if you want me to proceed. What is explainability increases? Okay. 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 Any other doubt? Okay. Let's say what is explainability increases now. Take a screenshot, guys, if you want, because notes will be not be provided. So, and let's keep mobile nearby. uh, Next, where is the next page? Yeah. Explainability increases. This will come under explainable AI. There's a topic known as explainable AI. What it does, once you know, come to know about this, no, you'll come to know what I'm talking about. Explainability increases. So what it do? Okay, it will create. Sorry. Let's say you have 10 features. Everybody knows features, right? Features means column I'm talking about. Alright, yeah. Yeah. So 10 feature or column. You have 10 features and you're training a machine learning model, ML model, right? On this data. Right now what you have, is 10 features and you train the model, you got accuracy of let's say 90%. Then you did data pre-processing again, and you found that only feature extraction or feature selection, you did feature engineering, let's say you have done feature engineering, and in that you found that only 8 features are important, or these 2 features I want to drop, let's say 2 features I want to drop, that doesn't make any sense in my data. Now you have 8 features for the same machine learning model you're going to train, and your accuracy boosts up to 95% just by removing 2 features because they were not important for your model to be trained on, and that is not correlated also. And where did you get from? You get that from this heat map, multivariate analysis. Did you guys remember multivariate analysis? We plotted a colorful map. Yes. So from multivariate you analyze, okay, these two are actually not putting, and from the data also what I have the domain knowledge, these 2 columns are not important. So you drop that 2 columns. Now you're training your data on 8 of the columns, right? 8 features. You should not call it column, you should call it features. 8 features. Now you got 95%. What explainability increases? You can get this term right now. Okay, the data that is already processed now on this data, this one on which the model is getting trained, how much it is important, like why this result came like this only, why 95 I've got. The reason was heat map over here, and that correlation was very less. Okay, with two of any of the terms like this row and this column, something. So because of this correlation was very less, I dropped it. Right. Or something like explainable AI, what it does, when you train a machine learning model, no, it will automatically gives you क्या कहते हैं, order of your features, how much important based on their importance, right? How much they are important, what they are getting from heat map, no, more better way and more easy to understand with some values, right? Okay, particular values, we use this explainable AI to get the feature, how much something is important for it. For example, you are preparing to have a room or set up a room. Over there, you want to keep something, but the space is limited. So you will decide, okay, I'll keep a bed, I'll keep two chairs, one table, I'll put my laptop or something. So you give importance according to that. Or whenever you're packing your bag for a vacation or something, you remove unnecessary thing, which you just keep important things based on the importance, right? Same thing over here. Okay, how much this 8 features are putting the importance on the machine learning model, such that you can proceed with it further. We use explainable AI, and that's how explainability increases. You got the point. Like earlier, you have 10 columns with basic data pre-processing, and you got 90% accuracy. But right now, you're getting 8 columns, and accuracy increased for the same problem and having the same target column. Well, containing the specificity of the problem and still making good results, right? Keeping the necessary stuffs inside your data and getting the best and best result time by time, that is how you can tell your model is getting better. And for explainable, we use explainable AI. There are Lime and multiple are there. So one of the basic what I use all the time is Lime. So it gives you the feature importance, and based on that feature you select features, and we train the model. And why it is important? Because it's too much correlated. So based on the correlation we do. Any doubt till here, guys? Yes. Okay, guys. Okay. So before doing data pre-processing, we'll do a quick recap of data. So everybody know data. I'm not gonna talk about the data definition. There are multiple types, numeric types and categorical types. One more was there text type. One more was there time series. So numerical and categorical. Numerical have numerical values. Categorical have categorical values, where we can identify the things into categories, multiple categories, either car, either dog, either bag, either ball or something. Textual data. My name is Amitav or something, whatever. And time series is like today or yesterday there was no class, before that there was no class, before that no class, before that yes there was class. So something like that, if it is coming based on some time series data. For example, one of the prominent example, if you go at the NASA website, you can able to see multiple datas what they have from the different jet engines means they give a lot of values. They have a data frame where they have engine ID, then cycle count, and for every cycle, for example, and multiple components. See, this is the operations and some sensor data, and they give a lot of data. For example, engine 1 cycle 1, engine 1 cycle 2, engine 1 cycle 3, same way till it fails, till the engine fails at some due to some of the sensor or something. So for example, 19, the data, this was some data. Lekin next there is no data. Let's say 2 1 starts from 2 1 with the sum of the data. That means the engine failed at 119. So based on this preview, the data, some like time or something is there. This is time series, classical time series problem. Okay, how much time was left after 50% of the life decay? So let's say this much. Okay, where from what point, from what, for example, for an age we can say if a person, let's say for a person I'm talking about, he died at age of 70 or 50, let's say 60, at the age of 60, starting from zero. He has started from 0, 1, 10, 18, high. I'm talking about energy in this level. Energy was high for the age 40, 50, but slowly as body decreases, 55, 55, still energy was high, greater than that 0, 1. And for the further, for a normal person, it should go like this and die at 80 nearby. But for the 60, he died. But for the another person, if you talk, it went to the 80 or 75. So this is time series data. Okay, how much life was left, how much prediction of the life was left because of what was the incident it happened. So this is time series, right? It can be text data. We talked about text data. So in text data, multiple things also can come. If you further want to know, I want another data. Image is also a data, brother. You are not talking about. Yeah, actually, image is a data. So there are multiple types of data. Voice is also data. Video is also data. So you can call it miscellaneous, and in miscellaneous you can put all this. Right? This is the types of data. And to do data preprocessing, we use NumPy, Pandas, scikit-learn, matplotlib, or C, per, bas, khatam. We'll just. Sheesh. Okay. And one more important part, what I just made in a funny way, that was scikit-learn. I just got remember one thing. See, scikit-learn now, it is best library which you can use to train your machine learning model. But apart from training to do data pre-processing stuffs, multiple things are present in it. For example, scaling part, min-max scaler, standard scaler. So we scikit-learn. And what is min-max and what is standard scaler? We have already talked about it. How it works actually, I think so. No, we didn't cover how it works, but yeah, what it is, we have covered. Then encoding, in label encoding, one hot encoding, we have covered. Yeah, did you guys remember? So to do that, we use scikit-learn. Then imputation is mathematical imputation of your model, data. Or if you want to change something, if you want to correct the text or something, converting text into numeric data. So you can use scikit-learn. If somebody asks why scikit-learn is used for only for machine learning, no. This is scikit-learn is the one resource, only one resource where you have a lot of things for the machine learning, including model training, as well as pre-processing, as well as multiple more options are there. I forgot. So again, my matplotlib is for data visualization. Cbun is also for data visualization with multiple options. NumPy is for normal or efficiently working on numerical data, doing something handling of the what we say arrays. In NumPy, arrays are there. No, handling of the NumPy very efficiently. We use NumPy, like sorry, to handle arrays more efficiently and more fastly. We use NumPy. Pandas we use for data cleaning. We use for merging multiple data. We use to read the data. To get more insights, we just perform some of the commands presented in the pandas library, right? Okay, so there are multiple advantages of doing what we say this data pre-processing. Some of them are improving that accuracy. In that first I told you, no, the model accuracy improves, data quality increases, and blah 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 blah. Do you guys have any doubt till here? Any kind of doubt, guys? Okay, 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 okay. Now we'll talk about what are the major data pre-processing techniques we use every time while training the machine learning model, right? See, again, I'm not telling everything is necessary. It depends upon your data. But the point is, data should be pre-processed before doing machine learning stuffs on it, or any stuffs, any types of machine learning you're using or deep learning. Data has to be pre-processed. For example, it is more likely you are you want to cook uh, paneer masala, paneer tikka masala. Sorry, paneer tikka. Okay, after the class, I'm going to the restaurant now. Paneer tikka masala with butter naan, with some favorite sweet or ice cream. Oh my god. Guys, can we have a break of half an hour? We can continue later. I think so. I should order some food.
Yeah.
I'm joking. So paneer tikka masala. If you want to prepare paneer tikka, butter naan, or ice cream, you want to eat all three in the same time, same way. What you need to do, you need to get paneer like processed. Then paneer, once it is done, you want to have masala ready. Then masala ready, then chopping onions, tomato, and whatever the things required. Then again going for the this cooking part, frying and whatever we want to do. Then cooking, we will get one part is done, like 1/3 of the part, that is sabji is done, like sabji is cooked. That paneer is cooked now, paneer cooked. But for butter naan, again some process, roti and blah blah blah, maida adding in, cooking it in the that stuff. Then at the end we can say 2/3 of the work is done. Same way for the ice cream. If you want to prepare ice cream, you need what I think so, milk, some flavors, some ice, and some cream, and we cook it. That's it. So not cook it. Sorry, we freeze it. Then we got 3/3. Similarly, way data pre-processing means the same. When you have a raw data, see all the time I have the raw data, and just a second, guys. Ma, ma, क्या करने जा रही है? एप्लीकेशन उनसे मांग लो ना. आवाज कम कर दो. Yes. So this is how this is the what do we say? What do you say this? Raw material. We all the times have raw material, and we have some of the basics. Then we did some pre-processing. We did for here also. We did pre-processing. We then freeze it or whatever. So we did pre-processing by like cleaning it, washing the vegetables, chopping it. So this all undercomes pre-processing, right? This is the basic example how pre-processing means. And what is data analysis means? Finding out okay, this type of paneer is better, or this type of ice. This is how if you increase the quantity of milk, the smoothness increases, or something like that. The flavor increases as per the flavor. This additional flavor and the cream quality. So this is data analysis part. What we talked before is data pre-processing part. Did you guys clear what is the difference between data analysis and data pre-processing and how it is important? Put a thumbs up if yes. Yes. One thumbs up means one person's understood. 3, 4, 5. Okay, guys. Let's go with the major techniques. What we do. Like for the vegetable, has to be chopped. It has to be cleaned. Some of the basics are already there, but you don't have to chop. ये क्या कहते हैं? Atta, flour or like atta basically. You don't have to chop. You have to उसे क्या कहते हैं? बेलने को something. You have to do something else. Not like you don't have to treat it like vegetables. Similarly, way it depends upon your data to data how you have to treat it. It's not necessary all the time you have to treat the same way. Okay, some of them was the major processes data cleaning, the first and foremost. Data cleaning. What is data cleaning? We remove unnecessary stuffs. For example, we remove missing values. We normalize the data. For normalize we call it reduction. What reduction? I think so. I forgot. What we call it? Noise reduction. Reduction or removal, whatever you want to say, you can say. Missing values is done. Noise reduction is done. Then duplicates. Removing duplicates. We do this also. Outlier. Sorry. Outlier reduction and correction. Right. Or for example, you might have invalid data also, that 9 and 9 wala case. So that is invalid data. So if the case is invalid data, so what you will do at that time? So this is data cleaning unit, right? Okay, removing some type error might be there, or some format error. For example, uh, this is there, or like negative age, or age above 1000. That is not possible. Also, this will come under this, right? Or yeah, similar kind of stuffs. So this is the first step. Is it clear? Because I have already taught this, so I'm not going in depth. Okay, what is noise removal? What is duplicates removal? All right. Should I proceed with the second point, second topic under data preprocessing? If you want me to wait, just put a thumbs down. Okay. Okay. See, might be one issue will be there, which all the time multiple machine learning engineer faced, is data, lack of data. Lack of data. Okay. So you might find, for example, there is one disease known as multiple sclerosis. Sclerosis. Something is there. MS. If you type multiple sclerosis and MS, it will come. For this is a brain-related disease. Related disease which happens, I think, so due to some nervous system disturbance. Nervous system disturbance. Okay, like might be some that person fell from the bed or got head hit his head, something like that. So it happens due to this, or some damage inside your brain, some tissue damage, or it happens because of this. And neuron damage, you can call it neuron damage, multiple neurons damage, neuron damage, sorry, neuron damage. So what's the problem I'm trying to say? If you want to do analysis, you will find multiple image data, a lot of image data. But the point is, if you want to do it in machine learning using CSV file or any type of textual file, the point is you won't have very few, very few. Like I think so, two or three are only present, right? So what we have to do, if you want to, because you have to do the analysis on the multiple sclerosis, but you don't want to go for the deep learning part for the image processing, but you want to do based on machine learning. Reason being, okay, I know deep learning is good, it can filter out some of the issues, but how machine learning works? Machine learning is totally mathematical imputation, right? Based on the formulas. Deep learning is extracting that image data, then putting into and finding the trend. That is the deep learning. Deep learning is not machine learning. Machine learning is not deep learning. Deep learning is a part of machine learning, right? So you want to do machine learning part, and here you go for the very few data set we have. So what you can do, okay, that 2 and 3 you will just put one next to each other, right? So this is how you work. Did you guys getting putting merging multiple data to increase the number of rows in your data, or increase your data set, size of the data set, right? Any kind of issue, you can call this as data integration. This part known as data integration. You can take the screenshot or you can note it down. Or linking of data. Data linking also you can say. Should I proceed, guys? Put a thumbs up. Okay, any doubt? Anybody have any kind of doubt? Okay. Yeah, hello. If you have doubt, raise your hand. If no, I'll continue. Okay, I'll continue. Okay, then main part, one of the main topic comes, that is data transformation. where we transform the data. Right. For the data transformer, multiple things are there. First is normalization itself. Then we have standardization also. Sorry. Standardization. We have encoding. Then we have feature engineering or feature transformation, better you call it feature transformation. Right. So what is normalization? Basic, only one thing if you want to remember normalization is ki putting it in a particular range, particular common range, that is normalization. For example, just a second now. Normalization was okay if your data is too much having high like maximum value is different, minimum value is different, a lot of the difference is there. So to normalize it, what you can do, you can put logarithm or something. I told you, no, like 1024 and 64 was there, 10 and 6. So doing this is known as normalization, and we have already talked about it in our previous class. So like scaling the numerical data for common interval or in a very small range, rather than making it too much of ununiformity. Over here, yeah, we can get a uniformity, right? Consistency of the data, like 10 to 6 nearly range. But over here 1024 is too high, and 64, reason being I already told, computer and something, if you can remember. Then we come for the standardization part, right? Standardization part means ki you can call basically ki uh, putting your standard deviation in the range of 3 sigma and your mean as 0. In the mathematical term, you can call it as standardization. Or instead of 3, you can the maximum you can achieve is 3 mean. The minimum is 1 unit of standard deviation, that is 1 sigma. Right. That is standardization. X minus mu by sigma. There was some value, no? X minus mu by sigma. Right. You get the z value, and putting mu as 0, you'll get the different values, right, for the z. And that's why how you do the standardization. You'll learn this in probability statistics, and slightly we have discussed in the EDM session, I think so. Right. Okay. Now there is a encoding part, and in encoding we have already talked about label encoding, one-hot encoding. Label encoding is nothing but labeling as an integer for each of the values, and one-hot is creating each column each feature column based on the name of the feature and assigning the values zeros or one if it is present, right? Then feature transformation is nothing but your fourth topic, that is log transform, or you can put logarithmic transformation. You can put square root actually, and that was box. Sorry, square root means if you put square root of 1024 and this. So what is square root of 1024? Anybody? 2 power 10. 2 power 10. What is the square root of 2 power 10? Anyone? What is the square root of 2 power 10, guys? Any ML student, machine learning student who knows what is the square root of 2 power 10? This is the question for everybody, not a single person, not a volunteer question. Necessary question. Okay. Apart from this, correct. See, the basic thing is you don't have to think too much. Square root means half, power of half. 2 power, I have written 210, no, and square root means 2 power 10, and I need square root, that is half. Put 10, 5. That is the answer, 2 power 5. Right, you should know the basic maths. Okay, we'll go for the next part. I think so. Mostly it's done. What else? What do we have done? What we have covered till now? Okay. No, sorry. model performance, training time, underfit, overfit. There was why also, no? Okay, we deleted it. Why we have covered, then what is data preprocessing, what are the terms, then explainability, then model performance, training time, underfit, explainability. Yes, we covered all this. Then what is data, types of data, how we deal with the data, what is preprocessing means, and comparison with data analysis. Then data cleaning, what are the ways you can do for the data cleaning, what are the how you can add or merge two data, that is data integrity and linkage, new topic. Normalized standardization feature and encoding comes under this. And we have we have now what else. We didn't talk about merging, right? Okay, see, there is one more concept, merging of the data set, that is same of data integration. Merging means nothing but combining data set on a key feature, key attribute, you can say, not feature, key attribute. Combining data set on a key attribute. For example, uh, you have one data set, let's say multiple securities one only, you can take the target one, and another data set also have, you have target one. You just want to add both of them, right? So this is the common data you have, this is the common data you have, you just put it over here, you added this, and you will put it with the rest of the data, right? That is nothing but merging multiple data set or reshaping it, right? That is the basic thing, guys. That's it. I didn't get anything else from the data pre-processing. And for the numerical data, you have imputation, some imputation you do, that is normalization and standard. For categorical data, you do encoding or one hot encoding you do, or yeah, we did see. Do remember one thing: mean, median, mode. We use mode for the categorical, right? So if you find any null values or any values over here, not a number. NN stands for not a number. Null values or null. How you can remove it? You are going to remove with the mode values for categorical data, categorical column. For the numerical, you use mean and median, right? Accordingly. So you should remember this. And for the numerical, we do now see here no. This we do for numerical. This numerical. This you do for the categorical, right? So I think so nothing else. And time series and textual data we don't have to cover how we process for them. We talked about little bit of the tools, so we can talk. I'm just writing such that you should have TOOLs tools, NumPy, Pandas, scikit-learn, or Matplotlib, Seabird, SNS. NumPy to handle the data fastly. That is nothing but your numeric arrays. So it is more like a revision class, but the topic name is different. Pandas is nothing but when you want to talk about the processing part, how you want to do the processing of the data. Use Panda to manipulate, to handle the data. That's why you use this. For example, cleaning the data, like df.drop is null. It's like something. Then df.is null sum or whatever we do, no, drop NA, fill NA. So there are multiple in-depth topics are also there. And after this, if you want to merge also, you can merge left join, right join, what we have studied in this, no, data set, DBMS, sorry, database management system. Joining is there. Same way you can do in Pandas. If necessary, we'll do, but it is very rare, only until unless when we need a lot of data, right? So then sklearn is there, scikit-learn for you can use for multiple things. Model training you can get, model training. Then standardization, normalization, that comes under scaling part. Then encoding, you can do encoding, right? So sklearn is for this, Matplotlib is for visualization of the data, SNS is for Seabird, which is also used for visualization, but with some of extra benefit you have or extra features you get, right? So how you process the data? Simple. Check for the first thing you should always check, like you can call it as a workflow or steps, like what we use in creating machine learning model. First is, where is my cursor? Okay, sorry. First is explore your data. Explore your data, or come to know about your data. What we do, df.info and statistics, whatever we do, no? Okay, how many null values are there? That is checking for the distribution of your data, or how your quality is, how many null values are there, how is the distribution of your target value or something like that, or is there any issues in the data? For example, multiple data are copied, duplicates, like the same data again and again. So you can find this also. So is there something case like this? So first is exploration of your data. Second, cleaning part comes. Whatever the cleaning needed, required, do, like you can handle the missing values, null values. You can fill it up with an fill it, backfill or forward fill. We have already talked about this also. Then remove the duplicates if you want to clean. Explore your data. You can come. No, you can check. You're checking about the data. Knowing the data is explore your data. Cleaning it means now do whatever you want. You can find null values over here also in exploration. But now you explored it. Now you have to treat it. For treat, you will go for the cleaning part, right? Then if you have the necessary, I'm putting it an optional step. If you have the necessary, for example, you find that after removing the duplicates, now your data size is very less, 50 rows, and another data set you found with some higher rows, and you want to merge it after the pre-processing of that also. So you can merge it. That merging comes under here, right? Integration and whatever the transformation you want under your previous data set. So you can do this wisely over here. So this is the second optional step, not necessary. Then feature selection you can do, removing the unnecessary features to increase the explainability, right? So you can put it as reduction of features or something, reduction of features, or transformation, not reduction. Better is word is transformation of feature, where you can put feature engineering also. Then we go for, once we transform the features, we got the good features. Now getting the good features, we have to train the model. Again, to train the model, we have to split the data into two half, that is train data set and test data set. I think so first class. So test data set, let's say we want 80% of the data, train data, and test in 20%. So how you can split? So again, in the sklearn, no, scikit-learn library, we have one function called train test split. Train test split. This is a function present in scikit-learn already. You just have to pass at what dimension you want for. For example, okay. For example, how much you want? Let's say you have to pass key. Array. Just a second, guys. Sometimes. For example, you want the size should be 20. Like size is 0.2. Means 20% of the data is sent for the test and 80% of the data is sent to the training part, right? So while dealing with the sklearn library, scikit-learn, while training the models, we'll come to know about this, right? So once you get the training done, splitting done, then you go for the training part, right? Multiple times you train, or there is something called k-fold. You can go for the k-fold. Multiple foldings you need, k-fold. Multiple time training the same data on different data sets. Not the same data set, but I'll show you. I'll show you guys. One more thing, like you should not know, don't know right now, but k-fold is an interesting concept. Let's say this is your data, whole data. So what do? You and the train test split is this. Train is 80%, test is 20%, right? What do? Let's say this is the 20%. And you train the rest of the model on this. And this is the unseen data, right? This is the first iteration. Second iteration, what the same thing will happen to train the model is this time it will pick this 20%. This one and this one will be used to train, and this one will be used to test. Same way, multiple times you go for the third part, here 20%, and this will be test data. See, I'm telling you, test is representing by this one, train is representing by this one. So we are using this as, again, over here 30, 20, 50 and 50% over here. And over, this is 80, this is, again, whatever you want, you can put 20 over here, 20, 20, 40, sorry. This is 40, 20, 60, again 40, 40. So 20, 40 and 60. Again, we want to increase, you can increase till here 60. Now 20% for the test, and again 20% for the train. Are you getting my point? Like training on this data at the same time and testing on this, rather than taking all the time on the edge data or something random data, we are splitting our data into five different parts. Right? You can also decide how many folds you need. If you want 5 folds, 10 folds, how many folds you want, you can put it like this. That many times your model will be trained on, right, for the different data. Now what is the benefit of this? Your data, for example, coincidentally, like your data has a trend, it follows a pattern. At the starting something data is like this, after that some data is like this, after that some data is more big and getting more big. A different pattern is there, which is keep on increasing. But you train on the you tested your data set on this only, and you train for the rest of the data. So definitely your accuracy is not good, because over the size is very small and over here is something different patterns are going on, right? So you can see the size is increasing, but you tested on this, so this will lead to less accuracy. So to overcome this problem, we use k-fold mean. K-fold you can call it right now. No need to call k-fold mean accuracy or something. I'll tell you what is k-fold mean accuracy within a minute. So now you tested on this. So this will lead to the less results. So instead of doing this, what you will do? You will test on this also. Like you will train on this data, then you will train on this data, you will train on this data, and for every data you will train, and you will check for test on each of them, right? And then you will find the mean accuracy. Sorry, mean accuracy. K-fold mean accuracy we call it. Mean means adding all the accuracy divided by the number of folds. Mean accuracy. So this all the time it gives the better result, right? So this is one of the type of training method you can use. So this is how our class ends for the today, and this is the workflow also, or the steps to approach. So if you guys have any kind of doubt, you can ask me right now. Else, tata, bye bye, good night. I'll go to sleep now. So if you have doubt, you can ask. Else, and the recorded recorded videos will be sent by today. I don't know how when, but yeah, soon it will be sent. No notes for the this, like handwritten notes will not be provided. I'll prepare a PDF now for today's class, what we have learned today. Okay, if you have any doubt, ask me right now, please. Till then, I'll close the video recording.